Why, hello there, and welcome to How the Heck Am I Supposed to Do Stoichiometry with Mr. Saslow. All right, so here is our lab document. We are on the What is the Mystery Product lab document. We are starting with balanced chemical equation number 1. What we are going to do is I'm going to show you how to do the 4 steps of stoichiometry following our guided notes in order to get the answer. What we are doing here is we have started with some amount of this stuff. And we heated it up, turning it into something else. So I want to know, how much of that stuff did I make, if it was that? So let's start at the beginning. Step 1 is I need to know what the molar mass of NaHCO3 is. Okay, well, I do that by adding the atomic masses. So I know that Na is 22.99-ish. I know that H is 1.008. I know that C is 12.011. I know that O is 15.999. 15.999. All right, and I know that from the periodic table. So then the question just becomes, okay, well, how do I get my answer then? Well, as I said, add up all the answers, which means I'm going to do 22.99 plus 1.008 plus 12.011 plus, here's where it gets tricky, 3 times 15.999. And the reason why I had to multiply this by 3 is because there are 3 oxygens. I know there are 3 oxygens because there's a 3 right there. So I get out my handy-dandy calculator, and I'm just going to type this in really fast. 22.99 plus 1.008 plus 12.011. Okay, that equals, I'm just going to make a note here, 36.009. All right, now 3 times 15.999 equals 47.997. Just going to make a little note, 47.997. I add those two together, 36.009 equals, and it gives me my answer of 84.006. 84.006 grams per mole. Okay. Well, that is how I find molar mass. That's it. There is no other trick. Now I'm going to have you do the molar mass of sodium hydroxide. So my first question for you is this. How many sodiums are there? Okay, there is 1 sodium. So we're going to do 1 times the mass of sodium. What is the mass of sodium? Okay. I'm going to add that to oxygen. So how many oxygens are there? What is the mass of oxygen? And how many hydrogens are there? And what is their mass? All right, and when you do all that, what answer do you get? Okay, well, let's see. On my calculator, 22.99 plus 15.999 plus 1.008 equals 39.997 grams per mole. All right, there we go. That is how we find the molar masses. Next step, grams of reactant to moles of reactant. And here's the thing. You're going to start with the amount of reactant. This is something you calculated in your lab. So mass reactant. Then we're going to do something to it using the molar mass, and that is going to equal the moles of reactant. All right, let's go ahead and make that text size a little smaller so it actually fits. There we go. So my first question is this. Do I multiply by the molar mass or divide by the molar mass? Yes, I divide. I always start with my mass of reactant. Always, always, always. Okay, now, this part things get a little strange, right? Because we all have a different mass of reactant. My number is 5.00 grams. I'm now going to divide by my molar mass. What is the molar mass of my reactant? Yeah, it's 84.006 grams per mole. And that's going to give me my answer. 5 divided by 84.006. And I get this really tiny number. And this really tiny number makes sense. Because what I'm saying is a mole is a box. If I have 5 grams and it's 84 grams in a box, how many boxes do I have? Well, less than one. I have a tiny fraction of a box. If one full box is 84 and I only got 5, I do not have a full box. So I want a tiny number. All right. Next up, moles of reactant to moles of product. All right, well here, we're going to take the moles of reactant. Let's go ahead and make this the appropriate size while we get the chance. And we're going to do something with the mole ratio, and that's going to equal the moles of product. Okay, so according to your guided notes, do you multiply or divide by the mole ratio? Yeah, multiply. All right, question, what the heck is the mole ratio? Well, it's your recipe. It is how many moles of this stuff do I make per mole of this stuff? And you get that from your balanced equation. But check this out, man, it ain't balanced. So I'm going to do some counting. I see no subscripts, so there's 1 sodium on the left, there's 1 sodium on the right. There's 1 hydrogen on the left, there's 1 hydrogen on the right. There's 1 carbon on the left, and there is 1 carbon on the right. There are 3 oxygens on the left, and there are 1, 2, 3 oxygens on the right. This is already balanced. So what is the mole ratio? Well, it's 1 mole of that to 1 mole of that. 1 mole of this is made from 1 mole of this. Okay, so what do I end up with? Well, okay, I end up with 0.0595 moles of a reactant. Multiply that by 1 to 1. 1 mole product divided by 1 mole reactant. And that's going to equal, well, 0.0595 moles of product. I'm, just multiplying everything by 1. That's pretty fancy. Okay, and last step. Now that I have 0.0595 moles of my product, my question is, well, how do I get my grams of product? Well, take moles of product Ooh. There we go. I'm going to do something with my molar mass, and that's going to give me my mass of product. The question is this: do I multiply or divide? I multiply. The thing that I'm starting with is the thing that goes first. Molar mass is always second. Molar mass is always second. Molar mass is always the second thing. So why do I multiply? Well, if my molar mass is 39.997 grams per mole, a mole is a box. I'm saying, hey, if I got 0.05 boxes and it's 40 grams per box, how many grams do I have? Well, I'm going to take my number of boxes, I'm going to multiply that by the mass for one box, and that's going to tell me my answer. What is my answer? Yeah, okay, so 0.0595 times 39.997 equals 2.3, rounding, 8 grams of NaOH. Whew. All right, now I want to highlight the things that are going to be different between what you have and what I have. This number is going to be different. You're going to use your own number, which means this number is going to be different, which means that number is going to be different, which means that number is going to be different, which means that number is going to be different, which means that number is going to be different. So all of your answers are different, but all of your work times by 40, times by 1/1, divide by 84. All of that stuff is going to be the same. So there we go. There is your quick video, quicks in air quotes, quick video on how to do one stoichiometry problem. Hope that helped.